Okay, I'm going to take you through this warm-up worksheet. This ties into section 1.1 as well as 1.2. So at first, we're supposed to graph the function and its parent function and then describe the transformation, if any. So for this first one, obviously it's linear. Okay, we just see an x. It is a line. The graph is a line. So I'm going to quickly just sketch. The parent function is y equals x, which is just a line that goes through the origin up 1 over 1. Okay, so there's your parent function. That was y equals x. X was a 3, y is a 3. By that, now looking at this new rule, g of x is x minus 5. I'm hoping that you realize this. That's just the shift down 5. Okay, so now when you plug in a 0, you're going to be down 1, 2, 3, 4, 5. So our line now is going to start there, but nothing else has changed. It's still going to go up 1 over 1, so it's going to be the same steepness. Okay, so this is g of x. Okay, so original y equals x. By having a minus 5, it shifts all the points down 5. Okay, the next one, there's no movement. It's just quadratic. There's nothing to it. So this is the parent function. It's a u that opens up from 0. Okay, so there's a quick little sketch. It is quadratic. Okay, obviously number 3 is absolute value. Okay, because I see the absolute value bar, so we know it's, if I could spell, absolute value. And then I need you to be willing to see this. The most basic absolute value is just y equals absolute value of x. That looks like this. That opens up from the origin. Okay, if x is a 5, then your outcome is a 5. If x was a negative 5, your outcome is a positive 5. So that's y equals absolute value of x. Now, by having a plus 6 inside, okay, what I need you to realize is that's going to move everything to the left 6 units. And you say, why 6 units to the left? If I plug in a negative 6, if I let x be a negative 6, 1, 2, 3, 4, 5, 6, I'm going to get an outcome of 0. So this point now is shifted over. There's nothing else to this graph. Everything else is going to stay the same. So if I plugged in, say, a negative 5, I'm going to have a 1. Okay. If I plugged in, say, a negative 7, I'm going to end up with a negative 1 inside, but then the absolute value becomes 1. So it's going to be the same size v going up. Okay, it's just a shift 6 units to the left. Okay, here, this negative in front is going to be called a reflection. Okay, so a normal line, like we did in number 1, was going uphill. Okay, so it was going uphill. That's y equals x. Well, now I have a negative, which is going to be a reflection about the x-axis. So this point is now going to be here. Okay, this point is going to be up here. So like when I plug in, say, a negative 2, negative 2 is going to be a positive 2. So now the line goes downhill, left to right. Okay, so this is h. So just keep in mind, this is still linear. I should write the word linear. So it's still a line, but having that negative out front is going to be a reflection. And we're going to get this in our notes for section 1.2. Okay. For this, it says use a graphic calculator. We don't need a graphic calculator to describe. So I'm not going to draw these. I'm just going to hopefully point out that you know this is linear. And what we're going to see in section 1.2, we're going to know that that minus 1 is down 1. So it shifts that line down 1. This 4 in front, it's greater than 1. We're going to see that that's going to make that line much steeper. It's called a vertical stretch. Okay. Again, if you would type that in, it's going to be a line going up much steeper than just x. Okay, so just keep that in mind. Here, it's absolute value, so I'll write down absolute value. But I see a negative, which is a reflection, and I see a 2, which once again is a vertical stretch. That V, that upside down, it's going to be an upside down V, is going to be skinnier because that 2 in front. Okay, nothing else changes. Okay, this is quadratic. This is going to be the vertical stretch. Again, because it's a number greater than 1. And then this is up 7. So if we would type that into a calculator, in fact, I will type this one into a calculator just to show you. Let me reset my calculator. So here you can see what we're going to see is a very skinny u that is up 7. So I have 2x squared plus 7. So it's going to be up here, up at the top there. Right there is the starting point. So it shifted up 7, and it's going to be stretched out because of that 2. Okay, that's what I want you to be able to see. So looking at this, it is going to be an upside down because of the reflection. So it's a reflection about the x-axis. That's all we're going to do this year. So when we say reflection, it's understood to be about the x-axis. We're going to see this minus 2 inside with the x is going to be right 2. And then down 2/3. Okay, no, not even down 1 full block, is just down 2/3. So again, if you wanted to, you could type this into your calculator. Again, I'll verify all this in my calculator. I'm going to type in my negative, so make sure it's negative and not a minus, or you'll get an error. Your X button minus 2, and then square it. That makes it quadratic. I never wrote the word quadratic here. Quadratic. And then we're going to be minus. Now, when you see fractions, just put them in parentheses and divide. Okay, there's 2/3 into our calculator. So again, it's going to be upside down. It's going to be to the right and down 2/3. So over here, so right there, it's going to be to the right. It's not down quite a full. If I zoomed in on that, we're going to see that it's not quite down a full block. It's down 2/3 of a block. Okay, that's what I need your brain to be able to see. Let me flip this over. Okay, so identify the function, describe the transformation. So obviously, absolute value. And we're going to see that this is to the right 3. Now, this is confusing for a lot of students. They see the minus and they think, why is that not to the left? And again, on a test or quiz, if you get that mixed up, your brain forgets, is it right, left? Graph it. Okay, and as long as you know the difference between your left and right, you'll see this. So remember, absolute value is math key, push over, option 1. So there's my absolute value bars. I put in x minus 3 inside, and I'm going to see that this v is shifted to the right 3. There it is. So instead of being at the origin, it's now over 3 units to the right because of that x minus 3. Okay, this is a line, so it's linear. I'm hoping you're familiar with graphing lines. This would have a starting point of 0, -3, so it's down 3, and that 4 makes it steeper. So it's a vertical stretch. Okay. This one's quadratic. You say, how do I know it's quadratic? It's being squared. Okay. So once again, that 6 is a vertical stretch. If you graph that, it's going to be a pretty skinny U-shaped graph, and up 1. Okay, now this is absolute value. And I see that the plus 4 is inside. That's going to be to left 4. Left 4 and down 1. Okay. Again, if you need to verify that using a calculator, by all means, type it into your calculator to see that it's a shift to the left 4 and down 1. Here's a line again. So it's linear. This time the line's going downhill, so it's a negative slope. It's going downhill, but we call that a reflection. And again, just it's understood to be the x-axis. This is a stretch, a vertical stretch. and down 10. Okay, here's a reflection, again, about the x-axis. We know it's quadratic, and it's down 5. Okay, last section. It says graph the function. As long I'm not going to make you graph on without providing you a graph. So just understand, have the graph in your head, and all we're going to do is describe the transformation. That 2 in front is a vertical stretch. It's making that line go uphill steeper. Okay, so it's still linear, still a line. This one is linear. It is a reflection, but since we have a 1/2, it's going to be a vertical shrink. Okay, that line is going to be flatter now. Okay, it's only up 1/2 if you or down 1/2 if you think of it that way, where it's the line's being compressed. Okay, because it's a number between 0 and 1, it's a vertical shrink. So again, the next one's linear, and it's simply down 4. Okay, this one's quadratic. By having that 2 in front, it stretches that U out, making it skinnier. It's going to be a vertical stretch. Okay, obviously this is absolute value. And again, since it's inside the x plus 4, it's going to be to the left 4. Okay, think about plugging in a -4 to get that same outcome of 0. Okay, without that plus 4 inside, 0 produced the absolute value of 0, which is 0, had a 0 as an outcome. Now I'd have to plug in a -4 to get that same outcome of 0. Okay, this is another absolute value, but this time it's to the right 3 and up 2. Okay, and now I'll show that graph just to make sure that you realize. In fact, I already have the x minus 3 already in my calculator, and then I'm just going to go on the outside and put a plus 2. So now it's a v that's shifted to the right 3 units and up 2. Okay, now again, if I had a number in front that was greater than 1, that would be a skinnier. It would be the v would be stretched to make it skinnier if it was a vertical stretch. If I had a negative, that v would be opening down. Okay, so that's all the stuff I need you to be able to force your brain to see and understand as you go through section. If you go back and look at the Big Ideas 1.1, this should make a lot more sense. And then as you do 1.2, it should really start to click. Okay, thank you for watching. That took me 13 minutes.